Hi there, graders. It's good to be back. It's Monday. It's a brand new week. Hang in there. It'll go by fast. So let's go ahead and take a look at your DMA for today. Remember, keep coming back and reminding yourself and practicing these skills that we've been working on. Okay, so let's take a look at our first problem. It says divide the square into sixths and shade the pieces to show 1/6. So remember, we are going to partition the one whole square. This is one whole, and we're going to partition it into sixths. Now remember, before I partition this, I can write one whole as the fraction of 1/1. Okay, so remember when we talk about whole and we don't partition it into any pieces, we can use that as our denominator as 1, and then however many whole we have, we could use that as the numerator. Okay, so if I had another square and I didn't partition it, then I could write that as 2/1. Or if I had 3 squares, whole squares, then I could write that as 3/1. So just wanted to remind you about that. I am going to start partitioning your square or the square into sixths. So I could start at half and take each half and break it up into 3 more equal parts. Or I could start with thirds and I can partition those thirds into 2 pieces. So when I say half, okay, so I'm just going to put that there. Okay, so if I have half, I could take each half and cut it into 3 more pieces to make sixths. So now I have 6 equal pieces instead of 2 equal pieces. Now, my numerator, it tells me to shade in 1/6. So right now, 1/2 is not going to be equivalent to 1/6. It would actually be equivalent to 3/6. But I just wanted to show you how you can use this denominator of half, partition it into 3 equal pieces, and you get 6. So I'm just going to erase that because we don't want 3/6. We want 1/6. So it says shade in 1/6. Now it doesn't matter which one you shade in as long as you shade 1/6 pieces. And I'm going to shade that piece right there, and I'm going to label it 1/6. Now remember, each one of these parts is a unit fraction, meaning it's one unit is 1/6, and this 1 is shaded in. Okay? Now the next problem is a pattern, and we are noticing that from one number to the next number, we're trying to figure out what is happening. Are they adding, subtracting, multiplying, dividing? So let's see what we notice here. We've gone from 89 to 85 to 81. Now, we know that we are counting back. And so we're not increasing in numbers, we're decreasing. That means we're going down in numbers, which means we're not adding anything to 89. We're subtracting, possibly. Well, let's check. 9 to 89 to 85. Well, count backwards. What comes before 89? 88, 87, 86, 85. So we subtracted 4 from here. Now let's see if that happens in the next set of numbers, or 2 pairs, or pairs of numbers. So 85, let's count back 4 more. 84, 83, 82, 81. So we subtracted 4 there. So since this seems to be what's happening each time, we can do the same thing and continue this pattern. So our rule, the rule to this pattern is subtract 4. We're going to subtract 4 each time. So to do that, we are going to subtract 4 again. So 81, we count back 80, 79, 78, 77. So when I subtract 4 more, that's going to be 77. So I'm going to place that here. I'm going to subtract 7 more from 7, or excuse me, I'm going to subtract 4 more from 7. And if you know how to subtract 4 from 7, right, that would be 3. So if I go 76, 75, 74, 73. So when I subtract 4 more, that's going to be 73. So I'm going to place that number here. Now I'm going to subtract 4 more. I could subtract 3 and then 1. So if I subtract 3, which would be 70, and then 1, which is going to be 69, that's subtracting 4 more. And notice how I just broke this up to make it easier to subtract in my head. I'm subtracting 4 still, but I'm subtracting it using this 3 and then 1 more. Just breaking those numbers to make them easier to subtract mentally. Okay, now let's take a look at our next set of equations. We are looking for the product, and remember your product is the total number of objects when you put the groups together. So I have one group of 8 is going to be 8. Now, if one group of 8 is 8, or actually maybe I should break this up a little differently. If we don't remember using our distributive property, we can break up one of these factors to make it easier for us. And I like to use 7 to break it up as 5 and 2. So 5 and 2, I can do 5 rows of 8, then another 2 groups of 8, or 2 rows of 8. Well, 5 times 8 is, if you don't remember, count by 5s, right? It's going to be 40. And then 2 times 8, right, is 16. And when you put that 40 and that 10 together, that's 50. And we put the 1s in the 1s place, so we have 56. So 7 groups of 8 is 56. Or we could break this 8 up as 4 and 4, right? And 7 times 4 is, and 7 times 4 is, this is 28, and this is 28. 8 and 8 is 16. Carry the 10. 20 and 20 is 40, plus 1 more 10 is 50. There's your 56. So again, a couple of different ways to look at it. You could break up this factor, which I like to do because I like to break up 7 as 5 and 2, and then multiply by the other factor. Or break up the 8 as 4 and 4, and multiply 7 times 4 and 7 times 4. So maybe you can come up with a different way to do that. All right, let's take a look at the next one. It's division. Remember, division is you take the total objects, you break them up into groups, or the number in each group, and you look for how many groups you have, or the number in each group, depending on how you use this divisor. So let's talk about using 3 groups and breaking up these 12 equally into 3 groups. So I could start by putting 1 in each, or I could even do 2s since 12 is an even number. But I'm just going to start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, how many were in each group? Right, 4. Remember, you can also use your multiplication facts to help you with understanding division. So if I have 3 groups of something, what am I going to need to make 12? Well, 3 groups of 4 is going to give me 12. All right, now we're going to take one more. And again, this is going to be a fraction problem. Remember, this is a whole circle. It's broken up into 8 equal parts. This is one whole circle. It is also broken up into 8 equal parts. Now, remember that each one of these is 1/8 of my circle or my whole. So this tells me that this is going to be 8/8. And this circle, since it's all shaded in, is also 8/8. So if I count my 8s, there's going to be 8 in this hole, and there's going to be 8 in this hole. So 8 and 8, how many 8s am I going to have? I'm going to have 16 8s, which is making 2 whole on the number line. So if I were going to put this on a number line, again, you have 0, you have 1, you have 2. 1, 2. If I break it up into 8 equal pieces, these are going to be tiny. Start with half, then fourths, then eighths. Once I count all of these, there should be 8 8s here, and there should be another 8 8s here, and that's going to give me 16 8s. Oops. Sorry, guys. So I broke this hole up into 8 pieces, and I broke this hole up into 8 pieces. All right, time for discussion question. So this is what I want you to do for your discussion. I want you to go back to this problem, this first problem that we had, and I want you to give me an equivalent fraction. If I were going to shade in a second piece, what equivalent fraction in simplest form is equivalent to 2/6? So what equivalent fraction in simplest form is equivalent to 2/6? Okay, you guys are getting pretty good at these fractions, so I'm interested to see if everybody gets this correct today. I think you will. Have a great day, and I'll see you in small group. Bye.